This video is the next in our series running through complete walkthroughs to the free response problems from the released 2012 AP Calculus A/B exam. This is free response question number 4, that's non-calculator. Now this problem is a great mix of procedural task-based calculations that you can get really good at practicing. So if you've been doing that, some of these might be straightforward, but there's also a mix of more conceptual problems that require you to think through what's going on under the hood a little bit more. Without further ado, let's dive in. Throughout this problem, we are working with a function f of x that is defined to be the square root of the quantity 25 minus x squared. Now part A is a nice gentle introduction. We're just being asked to calculate the first derivative of this function f. Now, when I look at this function, I notice I can write it as 25 minus x squared to the 1/2. Now, I've done that because it's going to help me take the derivative as soon as I spot that this is a chain rule question. There is an inner function and an outer function, right? F is a composite function. So the inner function, what is happening to my variable x, first of all, is, well, I'm taking the square of it and I'm subtracting it from 25. What happens then? Well, I have this outer function, which is raising that quantity to the 1/2 power, taking the square root of it. That's really helpful because now I can just apply the chain rule to calculate the derivative of this composite function. So we'll remember, we take the derivative of the outer function. So in this case, that was the 1/2 power, that square root. So when I take that derivative, I just use the power rule. So that's my derivative of my outer function. The chain rule tells me to evaluate that at the same inner function, so 25 minus x squared. But I need to remember what the chain rule says to do. That is multiply by the derivative of that inner function, 25 minus x squared. So we need to keep going here because we do want to make sure that we are calculating all the derivatives to get full credit. So this is 1/2 25 minus x squared to the negative 1/2. The derivative of 25 minus x squared, that's just a polynomial, is negative 2x. Now, you don't need to fully simplify on the AP, so don't waste time on that under exam conditions, but here we can do a little bit of simplifying to get our final answer is negative x over the square root of 25 minus x squared. So that is our final answer. Now here, how the points divvied up, well, we just get 2 points. For that final answer, it's sort of all or nothing. So that's part A. Before we move on to part B, I want to point out quickly, it was worth simplifying here because we're going to work with that function quantity in later parts of the problem. So if we didn't simplify now, we'd have to simplify later. We don't know that on the exam, of course, when we're having to work with this under exam pressure, but I just wanted to point that out now. It was worth our time in this video simplifying. In part B, we're asked to find an equation of the tangent line to the graph of this function when x equals negative 3. In the equation of a straight line, we need to know slope and a point on the line. So slope and point on the line. Well, the slope we need to know is going to be f prime at the x value that I'm interested in. So let's figure out, first of all, what f prime of x is. Well, I figured that out in part A, right? It was negative x over the square root of 25 minus x squared. So if I substitute in negative 3, I get negative 3 all over the square root of 25 minus negative 3 squared. Let's tidy this up a little bit. Those negatives will cancel. I'll get 3 over the square root of 25 minus 9, which comes out as 3/4. So I have found my slope. That is great. Finally, I need a point on the line. Well, I know I want x to be negative 3. That's what we were given. For y, I just need to find out what f of negative 3 is. That is the square root of 25 minus negative 3 squared. We already figured out that is equal to 4. So I also now have my point on the line. To find the equation of the tangent line, I'll now use the point slope formula. So the equation of the line is y minus the y coordinate 4 times the slope. That is equal to the slope, which was 3/4, times x subtract the x coordinate, negative 3. I could tidy this up. I could put it into slope-intercept form, but I don't need to. This is perfectly acceptable for the AP's point of view. So how are the points divvied up here? Well, I get 1 point for calculating the slope correctly, and I get 1 point for this correct equation. So far, this FRQ has been all about calculation, hands-on, concrete stuff. That's all about to change with part C, where we're asked to work with the definition of continuity. So we're still working with that same function f, but we're using it to cook up a new function g that is a piecewise defined function. So when x is less than or equal to negative 3, we're using the rule f. But as soon as we pass over to x being larger than negative 3, we're using this linear function x plus 7 for g. And we're being asked at that transition point, right, at x equals negative 3, is this function continuous or not? With piecewise defined functions, when the rule changes, sometimes we can have jump discontinuities, that sort of thing going on. So here we're trying to work out exactly what is going on with this function. So first of all, we need to answer the question, g is continuous at negative 3. Well, the definition of continuity says that the limiting behavior, so as x approaches negative 3 from both sides of g of x, should equal exactly what the function g does at that x value. So what the function looks like it's doing as we approach x equals negative 3 is exactly what the function does at that point, x equals negative 3. There's no last minute plot twist where g of negative 3 jumps away to some different value than you were expecting. So we need to figure out a few quantities here. Okay. What is g of negative 3? And what is this limit if it exists? Well, we understand what this function g is doing from the left and from the right. We have those two rules, so we can use two-sided limits to figure out what is going on here. So let's figure out the limit as x approaches negative 3 from below of g of x. Well, when x is to the left of negative 3, it is that top rule that's deciding what g is doing. So that is going to be the same as the limit of the function f of x under the same conditions. And we know the rule for f is the square root of 25 minus x squared. That is a nice continuous function on its domain. It's a polynomial, you've got a square root involved. Those are all continuous pieces joining together to make a continuous function. So to figure out this limit, I can just substitute in x equals negative 3. That is the great thing about continuous functions. Again, it's that same quantity, square root over of 25 minus negative 3 all squared. So that is just going to be 4 again. So that's my left-hand limit of g. Let's figure out the right-hand limit. So the limit as x approaches 3 from the right of g of x. Well, at that point, it's the second rule coming into play when x is larger than negative 3. Oops, that was supposed to be a negative. So the rule is x plus 7. Again, that's a nice continuous function, so I can just substitute in negative 3. So this is negative 3 plus 7. That is indeed 4. These two left and right-hand limits agree. So that tells us we're in good shape because that left-hand side of the equation in the definition of continuity not only exists, it equals 4. So this left-hand side is 4. To answer the question of whether or not g is continuous, I just need to figure out what is that right-hand side equal to. So let's figure out g of -3. Well, at -3, it's that top rule that comes into play. That is going to be f of -3. And we've already worked out several times already that f of -3 is 4. So indeed, that right-hand side is 4. So yes, g is continuous at x equals -3 because the limit as x approaches -3 of g of x is equal to g of -3. Wonderful. So how were the points divvied up here? Well, we actually did quite a lot of work for only not too many points. So we get 1 point for considering left and right limits. So the one-sided limits from either side. It just says consider in the answer key, so we don't have to do too much more than that to get our point. So that is nice. And the final point we're getting is this answer of yes. But we also need to have this justification, this because. So they really made us work pretty hard here to get that second point. Right, the home stretch, part D, final part of the problem. We've got that conceptual stuff out of the way in part C, and now we're back to a more calculation-focused problem. It is an integral. It's a definite integral. It's not quite as straightforward as with a derivative where we just knock out our techniques that we've been practicing. We do need to figure out the right strategy with a different integral, but if we run down our checklist of possibilities, we'll find the right approach without too much problem. The first thing we should check is this one of my standard antiderivatives I'm expected to know? Well, no. I sort of run down my standard ones, my power rule, my trig, that sort of thing, and I see this as not a standard antiderivative. So what's my next best strategy? Well, the next thing I like to try is always integration using substitution. That looks quite promising here for a few different reasons. First of all, I have a product. I have that x term. And then I have this second factor multiplying it. And what's more is I have this piece under the square root whose derivative is something like that x that's hanging out outside. Okay. Namely, if I take the derivative of 25 minus x squared, I'll get -2x. I can kind of work with that and make that look like x using the substitution method. So what we're going to see is that x dx symbol pair is going to allow me to use substitution. So first of all, let's take u to be 25 minus x squared. That's what's clued me into maybe being able to use substitution here. Well, that's really helpful because when I take the derivative of both sides, symbolically, I'll get du is -2x dx. Of course, what I see here in my integral is x dx. So let's rearrange and write x dx is -1/2 du, just dividing both sides by -2 there. So my x dx pair, I'm going to be able to substitute in the next line. Now, we should also, because it's very easy to forget this, figure out my limits of the integral are in terms of x. It's a dx integral. So when x is 0 or x is 5, I need to work out what u is if I'm going to turn that into an integral in terms of du. Well, it's pretty straightforward if I remember the relationship between u and x. So u is 25 minus x squared. So when x is 0, u is 25. And when x is 5, I get 25 minus 5 squared. That is 0. So I can rewrite this integral in one fell swoop in terms of du. So my 0 of x will become 25. My x being 5 will become 0. I then have my square root u, but I need to remember that x dx was replaced with -1/2 du. Okay. So x dx gave me -1/2 du. This is now an integral that I can calculate without too much bother. So I'll have -1/2 integral 25 up to 0. Well, just to really spell it out, that square root u is the 1/2 power. So I'll get -1/2. Let's reverse the power rule. So I'll increase the power by 1 and divide by that new power. 25 up to 0. I'll have some nice cancellation occurring there. So what I'll end up with is -1/3, 0 to the 3/2 minus 25 to the 3/2. If I work out what this is, remembering my exponent rules, I will end up with 125 all over 3. That's my correct answer. How are the points divvied up? Well, we get a lot of work. We get a lot of points for our substitution step. So actually getting to this antiderivative here, using substitution, that is going to be 2 whole, that's going to be 2 whole points for us. And we get 1 point for our final answer. So there you go. How did you get on with problem number 4 from the 2012 exam? It's a little bit more straightforward than problem number 3, maybe. If you haven't tried that yet, if you haven't seen my video, check out the full playlist here. If you want to see me run through the multiple choice problem solutions, I'll also put a link to that playlist here. Let me know in the comments how you got on with this problem. Keep an eye out for problem number 5 coming up soon, and I look forward to seeing you next time.